How are we able to monitor and control emissions in power production? This is now the discussion. You are very welcome to participate in this session. My name is Merja Mäkelä. First, we discuss the monitoring of emissions in power production. The monitoring of emissions is based on the self-monitoring by the industrial plants themselves. The monitoring follows the program and permit accepted by local authorities. Particulate matter, sulfur dioxide and nitrogen oxides are measured continuously. The evaluation and control of emission reports takes place by regional environmental authorities. Eventually, additional information may be asked for, or even environmental inspectors may pay visits. Let's look at working in a central control room of a power plant. The operators monitor production using computer and video camera displays. When needed, they make some control actions, start machines, for example. You remember that from combusting power plants, we get some nitrogen oxides, sulfur dioxide, particulate matter, heavy metals, and persistent organic pollutants. This is how it looks in a district heating power plant. Different kinds of fuels are combusted in the furnace. Flue gases with some toxic emissions are coming out. There are filtering and cleaning arrangements in the flue gas channel. Continuous emission measurement systems should be used in centralized power production. Emissions are measured in the stack and analyzed by the measurement system. The measurement values are automatically transferred to the process control system for monitoring. This case comes from a pulp mill. Cooking chemicals are combusted for energy production and chemical recovery. Current emission values are presented in the display of the process control system and monitored by power plant operators. Another case comes from a waste-burning power plant. Important emission values are measured online in the stack and presented in a process diagram display for operators. Here you see the current emission values. Continuous emission measurement systems are calibrated against reference standards according to norms, regulations and company policies. Ministry of the Environment sets goals. Centers for Economic Development, Transport and the Environment promote air protection. Regional state administrative agencies handle permits and municipalities control locally. SAIC provides EU with measurement data. Next, we discuss how to control and reduce emissions coming from power production. There are different interests in power production. In operations, the focus is on safety, production control and staying within emission limits. In businesses, the profitability with its fuel prices and emission trade plays an important role. Principally, there are three different ways how to reduce toxic emissions from energy production. Firstly, we may use cleaner fuels and processes. Secondly, we may utilize improved combustion technology, and thirdly, we should treat flue gases. We always get carbon dioxide when we are burning organic matters. Natural gas and biogases out of manure or waste, for example, don't make a lot of harmful emissions when they are combusted. We get a lot of emissions when we burn fossil fuels such as oil, coal and peat. Also some renewable fuels like biomass, black liquor or pulp mills and waste make significant emissions when combusted. Some energy production methods are free of emissions. This is the case with solar, wind and hydropower and with the usage of hydrogen. The use of nuclear reactions and geothermal heat does not make emissions, but there are problems with nuclear waste. In circulating fluidized bed boilers, the formation of nitrogen oxides can be reduced using low burning temperatures and circulating flue gases. Another NOx reduction method utilizes low NOx burners with advanced combustion air feed. Nitrogen oxides can be reduced using ammonia. The injection of ammonia in the furnace results a reduction of 30 to 50%, while the injection of ammonia or urea in flue gases gives 80 to 90% reduction. Sulfur dioxide emissions can be reduced if limestone is added in the combustion. This calcium carbonate makes in the furnace calcium sulfate, which can be removed together with particulate matter. Electrostatic precipitators are located in the flue gas channel and they aim at catching particulate matter. In this electric filter arrangement, negatively charged harmful particles stick to plates and are removed by shaking. Particulate matter can also be reduced using dynamic separators. In mechanical cyclones, flue gas is taken into swirls while particles are sticking to the walls of the cyclone and removed. Particulate matter can be removed using fabric filters. The flue gas flow is taken through a fabric and particles stick to the fabric. Shaking, pressurized air or ultrasound may be used for the removal of particles. A compact filter in waste combustion comprises dosing of activated carbon and slaked lime and mixing with dust. This fluid reacts with the toxic components of flue gas. Precipitated matters are collected in a hose filter. Here you see the chemical reactions which take place in the compact filter. This is a monitoring display of the compact filter in a waste-burning power plant. Here you see the status of the filter arrangement and the current emission values. The combustion of most fossil fuels makes plenty of carbon dioxide. Also, the combustion of some renewable fuels makes harmful emissions. Using advanced combustion technology and efficient cleaning methods, we are able to reduce emissions. Thank you for your attention and have a nice day.